So this is a walkthrough of the GCSE Maths Foundation Tier Practice Set 2 Paper 1 of the CGP practice papers. They're the ones that were in this envelope here. They were handed to you as you left school. They're the ones that we were doing for homework. It's the first time I've seen this paper, so bear with me. I do have the answers here to check, but I say it's the first time I've seen it. £378 plus 7,000. I'd write it like this. Bear in mind this is a non-calculator paper. I carried one there, so the answer on the line is 101,789. 12 squared means 12 multiplied by 12. 12 multiplied by 12 is a number that you need to know is 144. You can work it out by saying 12 multiplied by 10, and 12 multiplied by 2 is 120, plus 12 multiplied by 2 is 24, and then you can add those together. 4 lollipops cost £2. How much will 12 lollipops cost? Well, you've got 4 lollipops and they cost £2. If you want 12 lollipops, you're multiplying this by 3, and then you have to multiply this by 3 as well. £2 multiplied by 3 is £6, so this is £6, which you can do with 2 dots, 2 zeros, or after the decimal point if you choose. 2 quadrilaterals are drawn below. What's the order of rotational symmetry of a square? That means that when you turn it round, how many times can you turn it round and it is still a square? So if we took this point here, we turned it around 90 degrees, it would come here, so that's 1, here 2, here 3, and back to the original, which is 4. We have 4 rotational symmetries. How many lines of symmetry? Now here it's how many places can we fold it, and it folds exactly in half. With a rhombus, every side is the same length, and actually there are 2, one here and one here. How many lines? There are 2. Rotate the shape below 90 degrees anti-clockwise. Anti-clockwise is the opposite way to a clock. 90 degrees is a quarter turn. In an exam you can take a piece of tracing paper. I don't have tracing paper here, but what I'll do is take a plain piece of paper, which you should just be able to see this through. So I'm going to trace it onto this piece of paper. And then remember, we're turning it this way round. We're turning it a quarter turn. 90 degrees is here. And then we basically translate that onto here. So we draw it either through the tracing paper or through here, ideally with a ruler. It's 2 across, just checking that. I'm drawing it freehand for speed. Convert the following length into metres. 1 kilometre equals 1,000 metres. So if we've got 23 kilometres, this is multiplied by 23. Here we're multiplying by 23 as well. .7 centimetres, 100 centimetres equals 1 metre. So if we've got 6.7 centimetres, that's like saying 6.7 centimetres here. To get from here to here, we have to, what's the best way of looking at this? We have to divide. We have to multiply by 6.7 and divide. No, I know what the best way to do this is. Let's cross that out. So if we've got 1 centimetre, to go from 1 centimetre, we know that's 0.01 metres. We do that because we can divide this by 100. We take 1 centimetre, we divide by 100, and we get 0.10. So if we take 6.7 centimetres, and we divide this by 100, we get to 0.067 metres. Right, now the next prime number after 31. So if we go 31, 32, 33, 34, 35, 36, 37, 38, 39. Right, when we're looking at prime numbers, we can cross off all the even, well, we know it's not going to be 31 because it's after 31. Cross off all the even numbers. It's not going to be an even number. We look at 33. Well, divisibility by 3, we can check 3, the 2 digits, you add the 2 digits together. Is this dividable in the 3 times table? It is, so this number is also not here. 35, it's in the 5 times table, it's got a 5 digit at the end. It is not this one either. This one here, not sure about this one. Just going to check this one here while we're on it. 3, 9, we can add these 2 digits together. 3 and 9 gives us 9, 10, 11, 12. If we're not sure whether 12 is in the 3 times table, we can add those 2 digits together as well, which gives us 3. This one is not in the 3 times table. This one is my best guess, so I'm going to guess at 37 being a number. I don't know any times table that 37 is in. Find 2 factors of 60 that add up to 27. So first of all, I'm going to write out all the factors of 60. Seven doesn't go, 8 doesn't go, 9 doesn't go. So these are all my factors of 60. Find 2 factors that add up to 27. So I want to look down here and find 2 numbers that add up to 27. Here we've got 23. These, if you add these together, they make 23. So we want 27 altogether. Can I add 20 and a 7? No. 15. What do I have to add to 15 to get to 27? 5 and 7, which is 12. Oh, look, those 2 just there. 15 and 12. Questions. (3x plus 3y). Now what we're looking for are like common terms. So these 2 have got x's in them. These 2 here have got y's in them. So what we do is we add up the x's first. 3x plus 5x gives us 8x. 3y plus 6y equals 9y. And then we just add those together because it's all add. 8x plus 9y. A multiplied by A multiplied by A multiplied by A. Well, if we remember, when we are multiplying 2 things together, we end up with that number squared. So if we've got 4 of them, we end up with A to the power 4. Expand here. I'm going to do it with the grid method. I've got a 4 here, x, subtract 3 on the top, and it's a multiplication. So 4 multiplied by x is 4x. 4 multiplied by negative 3, I have an odd number of negatives, and therefore it is negative 12. And the answer is 4x subtract 12. You can also do this with the sort of rainbows at the top here. 4 multiplied by x, 4x. 4 multiplied, now you've got to remember it's negative 3, is negative 12. So you can do it that way, or I like it this way because it's a lot more visible. Dexter's baking some cakes. He has 1 block of butter. He uses 1/3 of butter in some cupcakes and 2/5 of the butter in some muffins. What fraction of the block does Dexter have left? Okay, so he's got the whole block and he uses 1/3 of it in some cupcakes. So this is the bit that's in the cupcakes. That's used up. And he uses 2/5 of the butter in some muffins. So if this was the whole block again, he if we separate it into 5, he uses this much on muffins. So it's this much here, this much here, add to this much here. Cupcakes plus the muffins. What we can do in order to add this bit and this bit together, we have to have them to be the same proportion, with same division. So we've got 3 pieces here and we've got 5 pieces here. Well, what can we do to get these 2 pieces the same? Well, we can look at it as a common denominator. What we're actually doing here is we're adding a third plus 2/5. And we know when we add fractions with different denominators, what we have to do is make sure we've got the same number of pieces. We can do that by splitting each of the top 3 pieces into 5 pieces. We could do it with 5 pieces on each of these. Long piece. Or we can split, and we can split these into 3. And how many muffin pieces do we have? 1, 2, 3, 4, 5, 6. So we have 6, 15, because they're actually 15 altogether. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. I have 3 sections, each with 5 in it. I have 15 pieces. Here I have 1, 2, 3, 4, 5 pieces, 15. And we can do that here as well. If we know that we want a common denominator here and here, we multiply the 3 by 5 to get to a common denominator of 15. It means we multiply here by 5 as well. Oh look, that's our 5/15 here. And then we're adding it to here, which we multiply by 3. Here we multiply by here, and we get 6, which is also what we've got here. And then we add these together, which gives us 11/15. 5/15 plus 6/15 is 11/16. 5 here, 6 here. We add them together to make 11/15. It gives you the answer as a fraction in its simplest form, 11/15. And we know it's the simplest form because 11 is a prime number. 69 people were asked what their favourite soap opera was. The results are shown in the bar chart below. Explain how it could be misleading. So when I look at this, straight away I can see that it's correct. It's got spaces in between. These are equal lengths. But I look at the scale. I look at the scale and it tells me it starts here at 20. Well, actually here in effect it's, what will it be? It'll be 19. But this is saying that stormy weather, there's in effect only 1 unit, but actually there are 20 units. So explain how it can be misleading. The vertical axis does not start at 0. And then you have to explain what the effect of this is. This means that it looks on the graph like, how many have we got here? 1, 2, 3, 4, 5, 6, 7, 8, 9, like Burlington Square, Bolton Square has, what did I say? 2, 3, 4, 5, 6, 7, 8 has 9 times more than stormy. So to get 2 marks, you need to say what, and then you need to explain the impact. Okay, so if it does say 2 marks and it's a word question, try and make sure that you've got, or make sure you've got 2 sentences that say different things. Florence runs a catering company. She wants to buy meat pies from a local bakery. Each pie costs £3.09. She quickly estimates that she will need to take 300 multiplied by 3 to pay for the pies. Without doing the calculation, how can you tell she won't have enough money to buy all the pies? This is an estimation question. It talks about estimate. And what is happening here is that she's rounding these 2 numbers here and here. she's rounding them to one significant figure. So we've got 310, which she rounds to 300. And she's got £3.09, which she rounds to £3. Well, what's the problem? She's rounded down the 310 to get to 30. She has also rounded down the £3.09 to get to £3. So this is indeed 900, but she's going to have more meat pies, 10 more meat pies than she's estimated, and it's going to cost her more money. So how can you tell that she won't have enough pies to buy money to buy all the pies? Florence has rounded both values down. 2 marks. Do I need something else in there as well? How can you tell? She's rounded both of them to explain how this affects. So again, you need to explain how the effect. So this is the what, and this is the impact or the effect. Rounded both values down, the actual price will be greater. Three teams are competing in obstacle course competition. Team A scores 15 points. Team B scores 30 points. The ratio of teams A, B to C score is 6 to 7. How many more points did team C? Whoa, this looks complicated, doesn't it? It's not as complicated. So what we're going to, as it seems, what we're going to do is we are going to write down what we know. We know that team A score was 15 points. We know that team B score was 30 points. We know there's also a team C, but we don't know what the score is yet. We know that the ratio, we need the ratio of B to C is 6 to 7. So when we see ratios, one thing we can do is draw boxes. So here there are 6 boxes, and here there are 7 boxes. 2, 3, 4, 5, 6, 7. Now this 30 is the total score. We need to divide that 30 into these 6 boxes. 30 divided by 6 boxes. 30 shared among 16 boxes is 30 divided by 6, which is 5. So in each of these boxes, 5 plus 5 plus 5 plus 5 plus 5 plus 5 is 30. Now we know for C that there are 7 boxes, but because of ratio, it means that whatever is in these boxes is the same thing in each of these boxes. So there's 5 and there's 5, 5. 7 lots of 5. 7 lots of 5 is 35. So we know that the score here is 35. Then we're asked how many more points did team C score than team A. So it's a subtraction, difference. We want to know the difference between 35 and 15. So we take 35, we subtract 15, which gives us 20. So the answer is 20. 3 points. This is what was needed to get those 3 points. What fraction of all points scored was scored by team B? So what's the total fraction of all the points? We need the total score. So the total score equals 15 plus 30 plus 35. We need to know what the total score is. That equals 10, 1, 6, 7, 8. So the total score was 80, and we need to know the fraction of all points. We need it in the simplest form. So let's have a look. So the team B is 30 divided by 60. This is the fraction of all points scored by team B, and this is the total. We can divide top and bottom. numerator and denominator by 10. So we're going to divide by 10, divide by 10, which gives us 3/8, which is the answer. This is a 3 and this is an 8. Parallelogram, angle BAD, angle DB. Show that the triangle ADB is a right angle triangle. ADB is a right angle triangle. So there's either a right angle here and a right angle here. I'm going to have a think about this. Okay, got it. So this is a parallelogram. Properties of parallelogram. This angle here and this angle here are the same. This angle here and this angle here are the same. So we can immediately draw in this angle here, because this is 40, we can draw in this being 40 degrees. This is a triangle, angles inside a triangle. So we need to write a reason. So opposite angles so that's the first thing that we've written. We then know angles now I've used the word sum here. Angles inside a triangle sum to 180. That means they add up to. So this is the same as saying add up to. I'm going to use sum. It's the same thing. S-U-M, sum. Angles inside a triangle sum to 180. So if I've got a triangle C, B and D, this is 50, this is 40 degrees. What's this one here? Well, we've got 50 plus 40 equals 90 degrees. 180 subtract 90 is 90 degrees. So this must be a right angle. This is 90 degrees. It must be a right angle. This one here must be a right angle. But we need it for ABD. It's this triangle here, ABD. And we can say that these are alternate angles. We could work out that alternate angles is the better one here. So for alternate angles equal, therefore the angle ABD, the angle ABD equals 90 degrees. Therefore, triangle ABD is a right triangle. Question 13. What sort of correlation does the graph show? We need to draw a line of best fit. I'm going to get a pencil and a ruler. I need both to draw. There we go, pencil. Which direction do we draw a line of best fit? Well, it's in this direction here. That makes it easier for me to work out what the correlation is. If we're reading this line like a book, we're reading from left to right. The line is going down, so it is a negative correlation. By drawing the line with best fit, estimate Paula's average speed for a 10-kilometre run. So 10-kilometre run is just here. So I'm going to use my ruler again. I'm going to draw here. And then it's just a bit in between here. So I've drawn the line up to this line here, and then I've drawn across, and it's actually, I actually think it's nearer to this point here. So I now need to work out what the scale is. There are 5 squares in between 6 and 7, so therefore each square is 0.2. So what's the average speed for a 10 kilometres run? 6.8 kilometres. Paul generated another scatter graph to plot the distance ran against the time taken for each of her runs. What sort of correlation with this? Plot the distance ran against the time taken for each of her runs. So now what we're looking at is a graph. If we're thinking about the time taken, so the time, this is time, and this distance ran against the time, or we could put time here and distance here. If she ran 5 kilometres, the time would be, say, here, but if she ran 10 kilometres, would it be greater or smaller? It would be greater. So now the correlation is here. So the correlation is it would be positive. It would be a positive correlation because the time would increase as the it would be a positive correlation because the time would increase as the distance increased. A Venn diagram. It says there's a Venn diagram here as well, just in case you weren't sure. We've got 80 students altogether. They enjoyed swimming, reading. 28 enjoy both. So this is the 28. They enjoy both. 46 in total enjoy swimming. So therefore within this circle here, we've got 46. We need to have 46. Now we've already got 28. So if we take our 46 and we subtract 28 from that, gives us 6, 7, 8. But we had to carry 1. Gives us 18. So 18 plus 28 is the 46, 30, 46 that enjoy swimming. 10 enjoy neither. And that means we put it outside of these two circles, but within the set. That's what the rectangle represents. And therefore we need to work out what this final number is. We've got 80 students altogether. If we add the 18 and the 28, we get the 46 that enjoy swimming. The 10 that enjoy neither gives us 56, and then we have to take the 56 from the 80, which gets us 4 and 2, which gives us our 24. What's the probability that a randomly selected student enjoys swimming but does not enjoy reading? So they enjoy swimming but does not enjoy reading. There are 18 students that enjoy swimming but not, is that right? Enjoy swimming, yes, they don't enjoy them both. So we're looking at 18 students, randomly selected students out of the whole lot, divided by 80, but we need it in its simplest form. So I'm just going to make sure over here, I am going to divide by 2 to start with. Numerator and denominator takes me to 9 and 40. Can I do anything else from that? I don't think I can. 3, I can't divide by 3, can't divide by 9. So this is 9/40th, simplest form. Increase 80 by 35%. So what I'm going to do is work out what 10% of 80 is. So 10% of 80 is 8. 5% of 80 is half of that, which is 4. So then I want 35%. So I've got 10% here, another 10% is 20, and then another 10% is 30, 10%, 20%, 30%, and then 4, and we add those together. 3 multiplied by 8 is 24, 25, 26, 27, 28. Oh, it's not 28 though. It's all right, I looked back at the question just to check whether I'd answered it or not. A 35% increase is 28, 35% of 80, but it's not what we're asking at the answer. We want 80 plus 28. We need to increase 80 by 30, which gives us 108. So the answer is 108. Right, 36 as a percentage of 75. So the way to get a percentage is 36 as a percentage of 75, but we need it as a percentage. So what are we going to do? So this is interesting. I know that this number here, 75, is related to 100. If I divide this both top and bottom by 3, I can see 3's on the top here. So I'm going to start by dividing top and bottom by 3. 36 divided by 3 is 12. 75 divided by 3 is 25. I can now take that 25. What I'm aiming for is 100 at the bottom. And I'm moving this to get to that 100. So I now got 25, and I like 25 because I know that 25 is going to 100. So if I multiply top and bottom by 4, gets us to 48, and therefore this is 48%. So we've got a table that was bought for £56. This was 20% below the table's actual value. So this is the table's actual value. This is 100% here. We know that this is 20% less than the actual value. So this amount here represents our £56. This is 80% here and 20% here. Now, if we divide 80% into 20% pieces, we get 4 of them. So if we divide our 56 into 4 boxes too, 56, and use bus stop, divided by 4, 1 and 4, each of these will have £14 in it. Which means that this box here also has £14 in it. So we now take 14 divided by 5 boxes, which gets us 20, which gets us 70. So the actual price originally was obviously greater than the sale price, and therefore I've just double checked that. Yeah, 56 to 70 is the answer. The conversion graph below. Conversion means that we take one value, we take the line up to the diagonal line, and then we transfer the information across, either going from this axis to here or this axis to here. Estimate how many gallons are in 25 litres. So we find 25 litres. We use a pencil and a ruler. We take this up to the line and we're precise. And then we're precise on the way over here as well, and takes us to there. Now it's in between. This is 4. This little line here would be 5. And it's about halfway in between 5 and 6. So we're going 5.5 gallons. A truck can hold 20 gallons of fuel. 200 gallons of fuel. Use the conversion graph to estimate how many litres of fuel a truck can hold. So it can hold 200 gallons. Now if I take this 10 here, 10 is a factor of 200. So I take the 10, use my ruler. Oh, that's nice. It goes exactly on the intersection between the grid lines, and it takes me down to 45. So I know that 10 gallons equals 45 litres. So to get to 200 gallons, I have to multiply by 20. And here, if I multiply this by 20 here, I get to 900. However you want to multiply that up, I can see you multiply it by 2 and then you multiply it by 10. Multiply by 2, get to 90. 10 gives me an extra 0. I move everything one place value to the left, and then I have 900 litres. Work out this. Looks tricky, not as tricky as it looks. We have to write this. 1.5 times 10 to the power of 5. So what's that mean? Well, it's 1.5, and then we have to shift it 5 place values to the left. This is a big number, so I'm just going to write in some extra zeros. 1, 2, 3, 4. Let's write in a few here, and then we're going to shift it 1, 2, 3, 4, 5, and then I'm going to write my 1, 5 here, and then pad in all the way to the decimal point here. So this number, 1.5 times 10 to the 5, is actually this number here. And this number here is 9 times 10 to the power 4. So we do exactly the same. 9, I'm going to pad it with some zeros. We're going to jump 1, 2, 3, oh, the right number of 9, 0, 0, 9 here, 0, 0, 0, 0. This is where the point value would be, and this is where we stop. And now we have to take the two numbers away from each other. We've got a 0 digit, 4, 10, 1, 14. So the answer, give you answer in standard form. Okay, so that would get you 2 points to that point here. We now need to convert it back into standard form. We do that by moving, this is where the decimal point would be. We move it place values, 1, 2, 3, 4, 5, takes us to 1.41 multiplied by 10 to the power of 5. Just made a mistake. Let's try that one again. So this here is wrong, this here is right. So I got my zeros wrong. Can you see here? I've got 3 zeros and I've got 4 zeros here. So always good idea to check. 1, 5, 0, 0, 0, 0. 9, 0, no, I've done it again. 9, 0, 0, 0, 0. I've got 4 zeros. It's 90,000. 150,000. Actually, if I put commas in here, and 90,000 might be easier for me to do it. See, I made the same mistake again. I'm going to put the zeros in here. I need to subtract them. So 15 subtract 9. 15 subtract 9 gives us 6. 1, 2, 3, 4 takes us to 6 multiplied by 10 to the 4. 1, 2, 3, 4. 6 multiplied by 10 to the 4. That's better. Evaluate this. Now you can do it in a number of different ways. I'm going to use the lattice method. Now we're multiplying 7 multiplied by 8. I always get this wrong. So what am I going to do? I'm going to check it. So 8, 1, 8, 6, 8, 16, 24, 30, 6, 32, 40. So I've got 5, and then I'm doing 48, 50, 60, 66. No, 56. I just have a mental block around 7 multiplied by 8 for some reason. 56. 8 multiplied by 3, 16, 24. 1 multiplied by 8 is 0 and 8, and then this is 0, 0, 0 multiplied by anything. Bring this dot down here, decimal point down to here, and then I add across, add down 9, 10, so the answer is 0.1096. Okay, a correction. I managed to get my decimal point in the wrong place. The actual answer is 1.096. So it's not this at all, it is 1.096. Moving on. So this is wrong, the decimal point should be here. This should have gone down. We should have traced that down to there, and that's where the decimal point is. This one is wrong. Right, we're going to divide 114.3, going to divide it by 9. Doesn't go here, goes to 1 here, 2, 24. If you're not sure your 9 times table, 9, 1 9, 2 9s, 3 9s, 27. Oh, it's too much, so there's 2 of them that goes into here. Going from 18 to 24, 6, 63, there are 7. So it thinks of a number x, multiplies it by 7, and write down the result. So this is 7x. Andrew also begins with x and then multiplies it by 5 and then adds 18 and writes down the result. So we don't know what it is yet, but let's write 5x plus 18. We know that 7x equals this. They have the same, they write down the same result. So they think of the number here and they end up with the same number. So what we're doing here, yeah, x and x are the same, but also 7x and 5x plus 18 are the same. So we can form an equation. 7x equals 5x plus 18. Then we solve this by subtracting 5x from both sides, which gives us 7x subtract 5x is 2x, just 18 on this side, and then we divide both sides by 2. X equals 9. Make sure you put it on the line. Can't just write 9, you have to put in it as x equals 9 here, or you need to put it on the line here. Ideally put it on the line to get full marks. Bucket filled with water. Every minute 20 ml of water drips out of the bucket. At 12 o'clock the bucket is a third full. What's the capacity of the bucket in litres? So at 9 AM it is full. At 12 o'clock the bucket is a third full. So how many hours between 9 and 12? Well, there is, we've got minutes and we've got hours, so there are 3 hours difference. We're adding 3 hours onto here. So here it is a third full. So if it's a third full, then we've already lost 2/3. Okay, so that's what's left at 12 o'clock. At 12 o'clock. So we've lost 2/3 of the bucket. So in 3 hours, we've lost 2/3 of the volume. Now it asks us in minutes. Every minute 20 mils. Every minute 20 mils of water drips out of the bucket. So what are we looking at? Well, we need to convert 3 hours to minutes. We do that by multiplying by 60. 3 multiplied by 60. 180 minutes. In 180 minutes, every minute 20 mils of water drips. So we take 180 and we multiply it by the 20 mils. 180 multiplied by 20 is 36,000. And this is the total that was lost. So 3,600 is 2/3. So this here is 3,600. We need to divide 3,600 into those 2 boxes here. So 3,600 divided by 2, or halving it, is 150, 100, not 100, 1,000, 1,800. So each of these is 1,800. And how much do we have altogether? Well, it's 1,800 multiplied by 3. Gosh, simple multiplication and division, but it's putting it all together that's the tricky bit, isn't it? 4 to 5. So the total number of litres, let's check it's right. Yes, 5400 millilitres. Oh no, it's asked me to write it in litres. Oh, it's millilitres here. To go from millilitres, divided by 1,000 gets us to 5.4. So the answer is 5.4 litres. If you got to 5,400, it would give you 3 marks. And to finish it off, to get the full marks, you need to know and to check. Well, it says litres here, it makes it easy because it says litres here. To remember that you've got to convert it back. Always keep track of where your units are. This is a unit question. It's about units. and it's about converting units and knowing what you've got to do and when you've got to do it, thinking about your bucket and how full it is. Tricky question. 4 triangles are shown. Which 2 triangles are congruent? When we're looking at congruency, what am I looking at when I'm looking at these? Well, I've got 2 angles and a side. So the rule that we have to prove is AAS. Angle, angle, side. AAS, angle, angle, side. That means that we've got to go from the angle to an angle to a side, or so we've got to be able to trace our finger, angle, angle, side. We can't do that here, so on this one we need to find out what this angle here is. Angle, 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 side, 50, 100, 5. Can we find another one that's the same as that? Angle, angle, side, no. Angle, angle, side, 50, 30. So these 2 we know are not congruent because this is 50, 100, 5. Do we know? 50, 50. We don't know what this is. Let's find out the missing angle on each of these. Let's find out the missing angle. So we know that all angles inside a triangle, all angles inside a triangle sum to 180 degrees. So therefore, when we're working these out, we can go 50 plus 30 equals 80, 180 subtract 80 equals 100 degrees. So this one's 100 degrees. This one here, we've got 100 plus 50 equals 150. 180 subtract 150 equals 30. So this one here is 30 degrees. This one here, we've got 150 again, just like this one. So this one here is also 30 degrees. And this one here is 100 plus 60, which is 160 degrees. And then this one here must be 20. For them to be congruent, all angles and all sides must be the same. So therefore, when we're looking at these, if we don't have angles and sides that are the same, then we know that they're not equal. So this one here definitely isn't congruent, because although it's got the same side here, it's got 100, 60 and 20. There's nowhere else that's got a 20, so this one is not congruent. What are we looking at here? Angle, angle, side. So 50, 100, 5. Does that work with what we had here? 50, 100, 5. Yes. B and C are congruent. Congruent. B and C are congruent. I checked the spelling just here. Congruent. Let me just check where A is. So we've got 50, 100 and then 5. 50, 100, 5. No, because we trace our finger 50, 100. This one would need to be 5 for this to be congruent. We've got all the angles being the same, but the length of the side isn't the same. Angle, angle, side. 50, 100. And then you've got your 5 here. So B and C are congruent, and you need to state the angles, angle, side. And I've stated that this angles and side triangle sum to 80, because that's another reason why we can work it out. Question 22. Exact value of sine 30. Exact value of sine 30 is just one you've got to have to remember. It's 0.5 or it's a half, your choice. Jamelia is building a slide. She wants to build the angle between the slide and the horizontal ground to be 30 degrees. The slide itself is 4 meters long. How high will the top of the slide be above the ground? Now, we're actually only looking, although the ladder is a bit of a confusing, perhaps, we need to know the horizontal distance here. Not the length of the ladder, we want to know the horizontal distance here. If we're labelling this, this is trigonometry. We label our triangle. This is our triangle here. We label this as the hypotenuse. Now this is the angle, so this is the adjacent and this is the opposite angle. It means when we're looking at our triangles here, we're looking at, we want the H and the O, SOHCAHTOA, SOHCAHTOA. We're looking at our sine triangle here. We've got our hypotenuse, we've got our angle, we've got our hypotenuse, we've got our angle, we need our opposite, so opposite equals s multiplied by h. We know the hypotenuse, which is our 4. This is sine 30 multiplied by 4. We know our sine 30 is a half, so half multiplied by 4. Half of 4 equals 2. So therefore this length here, the opposite, equals 2, and we're in meters, 2 meters. Solve the simultaneous equations. So I'm going to label this 1, I'm going to label this 2. I'm going to take my equation 1 and I'm going to multiply it by 2. 1 multiplied by 2, which gives us 8a plus 6b equals 26. That's taking this equation here and multiplying it by 2. I'm just going to write my number 2 down again. 8a, just as it is, 8b equals 30. And then I'm going to subtract. I'm going to take my, actually these are bigger numbers at the bottom here, so I'm going to take 2 and I'm going to subtract 1 from that. 8a, subtract 8a gives us 0. 8b subtract 6b is 2b. 30 subtract 26 is 4. I can then divide both sides by 2. b equals 2. I then have to substitute that back into one of these. I'm going to sub it into 4a plus 3b equals 13. b equals 2, so 4a equals 3 multiplied by 2 equals 13. 4a 6 equals 13. And then I'm going to subtract 6 from both sides. 7, a equals 7 divided by 4. So a equals 7 divided by 4, b equals 2. And 24. Express 4,800 as a product of powers of its prime factors. So let's write it at the top, 4800. I'm going to take 48 and I've got it multiplied by 100. And then I can take my 48 here. This is prime number. What a lot of factors. So then what we're looking at is how many 2's do we have? So you could write it as 4800 equals 2 multiplied by 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 2. That's all of those. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6 multiplied by 3 multiplied by 5 multiplied by 5. Don't write over that line, I've written it out there so you can see it all together, which equals 2. For finesse we can write it here. You don't have to put the, oh actually for this you do, you have to put it as a product of powers of its prime factor, so we have to finesse it here. 1, 2, 3, 4, 5, 6 multiplied by 3 multiplied by 5 to the power 2. So to get full marks, to get the 3 marks, you actually need to write it as this. This here would get you 2 marks. This here on its own would just get you 1 mark. They're filling identical plastic cups. Given that this equals this, what's the largest possible capacity of the cups? So this is a highest common factor calculation. It's as if we'd have done 2 trees, one with 1,680 and one with 4,800. And therefore what I'm going to do is I'm going to draw a Venn diagram. And I'm going to look for what my common factors are between these two here. So the highest common factor is everything that would be in the crossover between 1680 and 4800, these two circles. I have 2 to the power 4, and outside on here I have 2 to the power 2. I have a 3 in both, I have a 5 in both, 2 to the power 4. I have a 7 here, I have 2 to the power 2, I have 3, and I have a 5 here. But I'm just interested in this piece here. What's the largest possible capacity? 2 to the power 4 multiplied by 3 multiplied by 5, everything that was in there. And then I need to work that through. So I've got 2 to the power 4. 2 multiplied by 2 is 4, multiplied by 2 is 8, multiplied by 2 is 16. So this is 16 multiplied by 3 multiplied by 5. Is there any... 2, 3. I'm just trying to look and see an easy... This is 16 multiplied by 15, and you can do this whichever way you want to do it. This 16 multiplied by 15 is actually 240. And that's it. I'm sorry if that was all off the bottom. I'll leave it on the screen. Basically what I did was I took the 1680, I put all of the common factors that were common to here and here in the middle section here. I then multiplied them all together. So I had 2 to the power 4, 3 multiplied by 5, and it got me to here.